A lot of people already knew about the variety of cephalopods, at least on higher taxonomic rank. Those that have shells are nautilus. Those that don't are coleoid. Coleoid are divided into two groups. Those with 10 arms are decapods, such as squids, while those with 8 arms are octopods, such as octopus. But what about this one? This one has shell. Surely this is nautilus, right? Well, no. This one is Argonaut. So, let me bring up the question. What exactly is Argonaut? Argonaut is an octopod. Well, to be precise, it's actually an octopus. Argonauts are their own family, Argonautidae, which consists of only one extant genus, Argonauta, but there are several fossils that belong to different genera. Argonauta is taken from the Greek argonautai, which is the Argonauts, sailors of the Argos ship. Some of you are probably familiar with Jason and the Argonaut. And yes, this is the same Argonaut. Fun fact, that's also the origin of Nautilus as a name. And another fun fact, Argonaut is the original Nautilus. We used to call these creatures Nautilus until we discovered the hard-shelled Nautilus. Then we called those pearly Nautilus, and Argonauts got the name paper Nautilus. Argonauts were called Nautilus because we thought they looked like a boat and their membranous arms function as sails, just like what's being depicted here. But that idea is obsolete. More on this in the later section. There are 4 valid species of Argonauts, which are Argonauta argo, the biggest one, Argonauta hians, Argonauta nodosus, and Argonauta norii. However, there are several other dubious species that might or might not be valid, still need further analysis. Argonauts can be found throughout the entire tropical and subtropical ocean. Sometimes, you could even see their case on the beach. Oh yes, I'm calling it case, not shell, because, well, let's talk about it in the morphology section. Argonauts are octopus, so they have 8 arms equipped with suckers on the ventral side. They also have the general octopus body forms: big eyes, mouth with beak, and siphon, aka funnel. Now, if you've been staring at this image, this might pique your interest. This is their membranous arms, the pair which are located on the dorsal side. Now, I did say the idea that they use this as a sail is obsolete. So what is it used for? The answer is to cover their case. Okay, so what's with this case? This case is not a shell. This is their egg case. Females carry this egg case around, tucking their mantle inside the case while they're at it. And yes, because this is not a shell, they are not stuck in it. They can detach their case. They hold this case with their suckers, and they don't let go, which is why we thought they are shelled octopus back then. This egg case is pretty much hollow. Meanwhile, shells of nautiloids have multiple chambers. Their egg case is also relatively thin and somewhat transparent, while the shells of nautiloids are hard and opaque. The egg case varies between species, so they can be used to identify them. This egg case carrying behavior is only for the females though. What about the males? Well, the males are just small ordinary guy, quite literally. Females of Argonauta argo can grow up to 10 centimeters. If you count their case, then it'll be around 30 centimeters. Meanwhile, males of Argonauta argo are less than 2 centimeters long. And remember, Argonauta argo is the biggest species. Other species is less than that. Males don't have the membranous arms. However, they do have specialized arms called hectocotylus. Fun fact, Hectocotylus was thought to be a parasitic worm that sticks to octopus. It was named Hectocotylus octopodis. But yeah, now we know that's a dismembered arm specialized for fertilization. I'll talk about it further in the lifestyle and behavior section. But before moving on, a reminder as always. Argonauts are pelagic animals, which means they swim freely. Oh, by the way, in case you aren't aware, this is a somewhat unique feature among octopus, because most of them are benthic creatures, crawling on the seafloor or sometimes floating slightly above. They mostly propel themselves with their funnels, but their egg case also have a role on their pelagic nature. They go to the surface, let air enters their case, and then use it as an air sac to control buoyancy. That way they won't sink, and they can control their vertical position in the water column. They are predators and they eat various animals that are smaller than them. They use their arms to pull their prey towards their mouth, and bite them with their beak. There are some articles that say they also have venom in their saliva like some octopus, but I cannot find any recent analysis on this. Oh, by the way, in case you are curious about how they eat, there is a nice video showcasing this, and it's not even 1000 views, so go check it out if you are interested. I'll put the link in the description. Even though they are widespread, we don't have that much data on their life cycle. Females construct their egg case since they are quite small. They secrete the materials from their dorsal arms, that is, the membranous pair that I highlighted earlier. If this egg case is damaged, they could also repair it by secreting more materials to it. As I said earlier, males have special arms called hectocotylus. This arm is used to store and transfer sperms to the female. They will insert the hectocotylus into female's mantle, and then detach them, and each goes their own way. Oh, by detach, I mean dismember. Females are often seen with multiple hectocotylus from different males. This hectocotylus can still wiggle around, and it'll keep being attached to the females for quite a while, which is why it's understandable that we thought these are parasitic worms. They could brood thousands of eggs inside their case, and these eggs are spawned in batches across multiple days. Eggs with different stages of development are often seen together inside the egg case. Just like many other cephalopods, they could also change color, which could help them camouflage themselves or possibly communicate with each other. The chromatophores pattern is apparent on the pearl larvae. These patterns were thought to be conserved between species, so it was used to identify the species. However, recent publication shows varieties of morphotypes within species. Oh, by the way, this is why they cover their case with their membranous arms, so that their case is also camouflage. One of the things that I found interesting about Argonaut is the fact that they are often seen hitchhiking on other animals. There are various photographs and even videos of them hitchhiking various animals. As far as I know, there is no detailed analysis on this behavior. Whether it's symbiotic, whether it's a forced hitchhiking, who knows? It would be an interesting research topic in my opinion. Like I hinted earlier, we have several Argonaut fossils of various genera. That's because their egg case is a hard structure that can easily be fossilized. Well, relative to the usual mollusk body, that is. Just like ammonites and nautilus, we can identify them based on their cells. Well, in this case, their case. No pun intended. Funnily enough, one of the Argonauts fossil was my introduction to the Argonaut, which is kapal from Sumatra of Indonesia. Kapal means ship in Indonesian language, which is kinda funny how both kapal and Argonauta is technically based on a ship. People should just name every single genus of Argonaut with ship's name or something similar just to continue the trend. Anyway, we thought Argonauts was just an octopus using shells from other animals to protect themselves and their eggs, just like how hermit crabs use shells of sea snail. And then later on the evolutionary process, they secrete and create their own, quote-unquote, shells, mimicking the shells that they used. Some also suggested they are relatively basal and closely related to the shelled cephalopods, which are all relatively basal, considering modern cephalopods mostly don't have shells. However, a relatively recent publication has shown that their case evolved independently. After all, their formation, structure, and composition are different from those found in nautilus. So yeah, not only it's intuitive, it's also genetically proven, which is why zoologists prefer to call these egg case and not shells. All in all, even though Argonauts are relatively widespread, we still don't know that much about them. As someone in the animal systematic field, seeing several dubious species with uncertain validity irks me, but at the same time, it gets me hopeful that perhaps there will be more species discovery soon-ish. Argonaut is my favorite cephalopod after all. Even though cephalopods are not exactly my research object, I'll be excited if there will be more Argonaut publication, especially the one that will resolve the taxonomic uncertainty. More observation and analysis on their life history and behavior is cool too, of course. That would be nice. But for now, let's just learn what is known. And that's all for now. Oh, by the way, I will be quite busy until early March, which means I won't be able to read comments. If you got any question or discussion, I would suggest joining our Discord server and ask them. Anyway, enjoy your day.